Okay, and a good morning to everyone. And that was Neil Young, Keep On Rockin' in the Free World. So if you didn't identify that one, Neil Young. And I don't know if it's Keep On Rocking in the Free World or just Rocking in the Free World. Rocking in the Free World. Probably Rockin' in the Free World. No G at the end of that. Today we're going to bring closure to the simple closed curve unit. And tomorrow we have a test on it. So we're going to first answer questions from problems you've done. I have an activity that I'm going to hand out to you that you're going to work on for the simple closed curves. But before we do that, the question. Do you have questions about the problems you've been doing on the simple closed curve?
The one we were doing in there.
Which one?
We were like two blind people looking for a light switch in the dark.
Okay, so there were questions earlier. Do you know which one it was, Adrian, or do you know?
Just setting up
The process?
It's not the one where you look for...
Is it finding the area inside? Is it on the test questions?
It's
Where
the one where you divide, not without the multiplication.
I need to have some better idea which problem it is you're talking about.
I was talking about when you're doing the graph in school, like getting
The area inside for a curve that you've drawn? Okay, so we need to summarize the 3 steps you're going through. Is that the idea? Okay.
I got the one where it's percent n times total area.
Okay, so we have 3 steps to go through. So I'm going to use the board space behind me, Will, and I'll go to that space now. That's my space. Okay, step 1. Okay, step 1. I need the area of the grid. So on the grid you were working, I think that was 2 1/4 by 2 1/4? Or what was the, no, that's bigger than that. So it must be 4.5 times 4.5. So that was 4.5 inches times 4.5 inches. And that's going to change with each grid. So we multiply and we get 20.25 square inches. And my guess is that's not where the problems are. Step 2. I'm going to now have the percent of points inside. So let me just use the one you did. 18 points out of 50, correct? And so you had 36%, or we can write it as a decimal as what? 0.36. Now note, this is only going to work for Adrian's curve. This isn't going to be the same for everybody because your curves are different. Now this is the step 3 that I think is the crucial one if you're going to memorize it. Now there's 2 approaches to this, but let's go through these 3 steps that I've been presenting to you. The 3rd step is to take your percent times the total area. So you take your percent and you multiply it times the area of the grid. So that's what you have in step 1, correct? So you're multiplying step 1 times step 2. So step 1 times step 2 will give you step 3. So I'm going to take 0.36, for this is just Adrian's curve, 0.36 times the 20.25 inches squared. And so what was the area in your grid? At 36, okay, what do we have? 27.28? 7.28. 29 inches squared. Now, if you don't want to use that process, what's an alternate that you can do? You can set up a proportion. So the other method, alternate method, you can take points in, total points, and that should be the same as what? This is the question. What ratio is this? Right side. No, but what should it be? The points in over total points should be the same as area in total area. Our argument is that we're going to get the same ratio either way. Now, substitute. What did you have? You had a total area, so I'm hunting for area in. You told me your total area was 20.25. Now, for the moment, I'm going to avoid putting the square inches there, just to make it a little bit easier to see. What were your points in? You said 18 out of 50 total, correct? So I have a proportion, and how do I solve for that proportion? Cross multiply. 50 times AI is going to equal 18 times, and again, please understand, I'm leaving the units out for the moment, just to make this a little bit more readable. And I want AI. I don't want 50 AI. So what do I divide by? 50. Get rid of that. So my area inside is going to be this 18 times 20.25 over 50. Now I want you to note something. This part right here, isn't that just your percent? So there's your percent times your total area. At this point, I am going to write inches squared. So what would I do in a calculator? I'd take 18 times 20.25, and I'd divide by 50. And do that in a calculator, just see if it works. Okay? 18 over 50. Instead, just take 18 times 20.25, divide by 50, and we should get our what? The 7.29. We can just slide over a little bit, Will. We get exactly the same number. Agreed? Now, which way? Again, I'm curious. Okay, how many like this way more? Nobody. One of you likes this. How many like this better? Let's slide over to we can get... Okay, I have 3 of you, 4 of you who like this better. Some of you don't like either one. Okay, so some of you say neither door A or door B. You aren't going to win any prize. Both work. You don't have to use one over the other. Your choice, but they are your choices. Now, let's slide back over here. Remember that problem number 3, I think, in the review test. Let's just go back and point out. And give me enough to pick up just this much here, Will, if you could, please. There. Alternate method. Now, in the alternate method with problem 3 in the test, is it number 3? Okay, it tells me the following. In number 3, it tells me, let's just write some information. Area of graph is what? 35 square inches. What else does it tell me? 25 points total, right? And then what does it tell me? 15 inside. Now again, you could take this and go what? Either method, no problem. I can say 15 over 25 is 60%, and multiply 0.60 times 35. Okay, number 4. Information in number 4. Notice how it's different. Number 4. This was number 3. For number 4, give me the same kind of information. 36 square inches for area of grid? Okay, so area of grid is again what? 36 square inches. Okay, AI, area inside, 24 or 9? 9 inches squared. Now what else is given? How many points? 100 points. 100 equals total points. Now with this one, does it make a difference which method you use? I'd say it does.
Not
because you can't get a percent out of this because you don't know the number of points inside. So you're wanting points inside. How many? So in this one, if I go back to my ratio, which is points in, that's what I'm hunting for, correct? Over total points, I know that. And the argument is that that's area in over total area. So in this one, I don't think you have any choice. You take this information. So I'm looking for points in. Total points 100. Area in was 9. Total area 36. Now that's a pretty nice problem, isn't it? No. No, it isn't. Because you have an area of 9 square inches inside and a total area of 36 square inches. You're hunting for the number of points inside. So now I need to have the number of points. Usually I give you the number of points inside, or you find that by plotting points. Now this is rather nice because I could cross multiply immediately, correct? I could say 36 points in, private investigator, PI, over, well, I'm going to cross multiply. So 9 times 100, and then do what? Divide by 36, get rid of that. That becomes a 1. So my PI, points in, I can reduce here, correct? And a 4. And a 4 into 100? 25. So I have 25 points. That problem doesn't lend itself well to percent times total area equals area inside, because you don't know the percent. Okay? Now let me try it that way nonetheless. AI equals percent times TA. Agreed? I know the area inside is 9. The percent times, and the total area is what? 36. But then what do I have to do? Divide both sides by 36. And so I'm saying 1/4 is my percent, which is 25 in order to do that. Okay, so to that extent, you'd have to have 25 over 100. And so that means you have 25 inside. That's not as obvious, I think. But it can be done. Again, you have two choices. I think this method is more complementary to the problem. But does that answer 3 questions, hopefully, in the process? How to find the area for the curve you drew. How to then do 2 problems in the test. Is there any question on that? Okay. Now, are we okay in plotting points? That's not a problem for us at this time? Any question on any other problems in the unit before we do the kind of problem I wanted you to try? Okay, so again, this is an opportunity to ask questions about problems in the unit, and then I have a handout I'm going to give to you, and then we're going to look at that in class, start it, and then you're going to finish it out for the supplementary problem for this unit, which then gets turned in with your book to get your credit. So I'm going to come back to center on that, and I'm going to ask for some help here. So Chris and Adrian, you're sitting there at the edge. Could you help get those out, please? And what I'll do is put this under the document cam. What everybody's getting is this problem we talked about the other day. There it is. My poodle. See the nose up in the air kind of thing? Fluffy tail, 2 legs in the front, the back legs hidden, but a poodle sort of prancing around out of something Disney would have done. Now the question, what's the area inside that?
5 by 5.
Well, the grid is what? 5 by 5. So set up the area. Step 1. Set up step 1 on scratch paper or something for a moment. And then where can you write that on this paper once you find that? Because I have a space for you, and it says what down here? Area of grid. So it's 5 inches by 5 inches. So you're going to have 25 square inches for the area of the grid here. Now I have a table for you that you can fill in. The ins and outs. So you're going to keep track of how many in and how many out, and we're going to start with 20 pairs of points. Then, what we're going to have to do is ultimately find the area inside my simple closed curve. And I've given you a place to get the percent. This calculation right here is going to be your percent. So your choice would be area inside is percent times what? The area of the grid. So these two numbers you get are going to be multiplied together to give this. Again, visually, the area of the grid times the percent will give you the area inside. We got it? So here's what I'm going to do as my selection of ordered pairs. I'm going to go to the book on page 136, but for what we're doing, I'm going to start with the last 2 columns on page 136. So turn to that page just so you can see what we're doing. And then for people who are watching this who don't happen to have the book, okay, I'm going to go ahead, and I have a 7-6 here, a 2-3, a 9-7, a 9-2. So what you're going to do is write these. This is a pair, 7-6. So 7, 6. Then you'd write 2, 3. So you're going to need a list. Or you're going to use the last 2 columns on page 136. So I'm going to ask, and I'm just going to leave that up there for a moment. What I'm going to do is write those down as ordered pairs so I can reference them as we do this. So write these numbers as pairs. That means you're going to plot these points. For every pair, you have a point. Okay, and I just lost track of where I was looking. So I have 1, 9. And I should have gone to 1, 4, then 4, 9. 3, 7 twice, then an 8, 3. We're going to get 20 points out of this, and I'll have these so everybody can see them in just a moment as we use them. And everybody's going to start this way, and then you're going to have to finish this up on your own. Okay, come off there for a moment, Will. Now what I've done is simply write these as ordered pairs. This is what I wanted you to do. So you have the 7-6, the 2-3, the 9-7, the 9-2, and so on. So I'll do these as we look at the grid. So at the moment, I need to take the book out of the way. Then I'm going to try to get these points so we can see these as part of what I'm doing. So I need to get the camera up a little bit. And let's see if I can make this work reasonably well. Okay, I think that's going to work, Will. So my first point is a 7-6, right? So we're just going to see what happens here as we try to plot these points so you can see this process. Now, I don't know if it's going to help if I get some more light on that. That probably is going to wash out the left side and make it harder to see. So what Will's seeing on the camera over there suggests this is better. See if I can some way get that to hold down better. So, and tighten it up. Okay, that makes it a little bit flatter, but it also shades it, doesn't it? Okay, so scratch that. I give up. 7-6, we'll take it the way it is. So I start at the origin and go over 7 and up 6. What did you find when you did that? Point in or out? Now here's my 7-6. I'm pointing to it, and that looks like it's outside. So I have 1 out. So I'm just going to keep track of the ins and outs. My next point is 2, 3. So I go over 2 and up 3, and that's clearly inside, correct? You can see the point. So I have 1 in and 1 out. Now let me stop at that point. I plotted 2 points. How many were in? 1. What is my percent in? 1 out of 2, which is 50%. So that would say after 2 points, 50% of my area is inside, so 12.5 square inches. Do you feel very comfortable with 2 points? I hope you don't. They might have both been out, right? And you'd have nothing inside, and you know that would be bogus. So we want more points. So we're hoping 20 does better. Let's go to the 9, 7. That's our next one. So I'm at my third point, 9, 7. Over 9 and up what? 7, and that is just out by a lot. I was in the wrong column, so I have another out. So 2 outs. Now a 9, 2, correct? Over to 9 and up 2, and that one is in. So out of 4 points, I have 2 in, 2 out. So I doubled my number of points, and I'm still at 50%. I'm feeling a little bit more confident, but not a lot. 4 points, not enough to write home about. Back to the problem. I'm at this point at 5, 3, correct? Let's come off there for just a moment, Will. I'm going to check these off, or I'm going to get lost here pretty soon. So these are the ones I've done. So I've done those 4, and I'm now at 5, 3, correct? So over 5 and up 3, do we agree it's in? Okay, so I have another in. Okay, the next one is 0, 3. Now, what do you do with the 0, 3? You start at 0, and you don't go left or right, but you go up 3. So what I just am plotting is the point 0, 3. So let's come off there. That was out. Agreed? So I've taken 2 more points. Okay, let's come back. 1, 9. So that's over 1 and what? Up 9, and that point is out. 4, 9. Over 4 and up 9. Now, what are you going to call that one? Okay, let's see. I'm going to put a little arrow up here. We're going to get a finer read on this. Let's come off there for a moment, Will. Okay, now I have the advantage of focusing in. Okay, do you see it's just barely out? If not, let's come off there for a moment. No, it isn't. Now, it is out. Do we agree?
Yes.
Okay. Coming off there, I need to put the point, but it was out. And let's see if I can get the camera back to where I can do something constructive here. That was what point?
4, 9.
4, 9. So before I go to there, let me cross these both off. Okay, so I was at 4, 9. My next point is what? 1, 4. So over 1, up 4, and that is clearly in, correct? So let's check our counts here. I have 4 in, 5 out. Do we agree? 4 in and 5 out, that's our subcounts. Okay, so that was, the one we just did was what? 1, 4. So I get to cross that one out. Okay, let me bring my list up higher. Okay, so we're ready for what? 3, 7?
Yes.
Over 3. Up 7. And that is in. Okay, so I have 5 in now. Then 3, 7 again, correct? I had it twice, so it gets counted each time. So let's come off there for a moment, Will, as I check off. That sounds like a Russian poet. Check off. Okay. Or if you listen to Car Talk on Saturdays, drop off and check off. Some of us watched that or listened to that evidently. Okay, let's come back to my list. 8, 3. Over 8 and up 3. What's the read? In. Okay, the next one is 5, 6. So over 5. Remember, I'm always starting from the 0. So over 5 and then up 6. And that's going to be this point here. And it is what? Out. Okay, so that was, the number just I did was 5, 6. So let's come off there again so I can check these. I'm down to now 8, 1. Near the bottom of the screen, I have 8, 1. So over 8 and up 1, and it's in.
Do you care if we write the points next to the dot?
You can write the ordered pairs next to the dot. I have no problem with that. It's just I find it a little bit messy in what I'm trying to show on the screen. So we just did 8, 1, correct? So let me move this up further. Okay, so I'm at 3, 5 now, correct? So over 3 and up 5, and that's where? In. Then I have 4, 1. So over 4, 4, 1. Okay, come off there for a moment. This is, bring it in close.
And 4, 1.
Okay, let's look at the 4, 1 is inside definitely. Now, if you still can't see that, just inside, so we're okay. So it's just like having a magnifying glass. I'm impressed. Can't get the camera back where I want it, but I'm impressed nonetheless. Okay, just a moment, Will. I'm having all sorts of trouble getting the camera located where I want it again. Okay, that last one was what? 4, 1? Is that right? And so that was this point here, and we said it was inside. So I need to count that inside. Let's come off for just a moment. That was 3, 5, 4, 1. So the next one is at what? 0, 6. And it's clearly what? Out, because you don't go left or right. You go right up to 6, and that is out. So let's come off there. I'll put that point in, and I'm down to the last 3. I have a 7, 9. So over 7, oh, you're kidding. Over 7 and up where? To 9. And so the question is that in or out? Now 7, 9 is right here, and you can see it's just barely out. Okay, so we have 7, 9 is out. I need an automatic return on this camera. 7, 9. So that was out. Our last 2. 1, 0. So that says go over 1 and don't go up or down. It is out. And finally, 4, 1 we said was what? In. I believe we are at break even. 10 in, 10 out. Do we agree? 10 in and 10 out. So what is your percent? So what we want to do now is fill in some information here. So I'm coming down to here. We said the area of our grid was what? We need to fill this in now. What is the area? Area of the grid.
I got 11 in.
No, I asked the question, what's the area of the grid? 5 by 5, 25 square inches. So let's come off there for a moment. I have 25 square inches. Now, I was keeping track down here in my in and outs, and I had exactly 10 in and 10 out as I recorded them. Now, it's a little bit hard when we come back and look at our points to see, but let's see what we can do. Let's just try doing a count here. Remember, one of the points was doubled up, correct? So we had a 4, 1 twice,
3, 7 twice.
and we had the 3, 7 twice. So other than that, I have what? Down here, let's count. 1, 2, 3, then 4, 5, 6, 7, So again, and this one down here was in. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And one of those was a repeat. That was this one down here. And the 3, 7, was that a repeat?
Yeah.
Okay, so let me put circles around the repeats. Let's come off there for a moment. This was a repeat. This was a repeat. Back to the circles. So I'm going to count the points again and then add 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and add 2. So I evidently have my counts down here off. We have 11 in and 9 out, correct? So that's 11 out of 20.
55%.
So 11 out of 20. So here's what I have. Just a moment. I need to put this inches square here. Okay, let's try that now, Will. This is the information. I need to bring that down a little bit tighter so you can see. I have 25 square inches here. I have 11 out of 20 here. And so this is what percent? 55%. So let's come off again. And I'll try to get rid of this weird angle on the camera. So let me write that as 55%. So this is my information now. So how do I find the area inside? What do I do with those numbers?
You multiply 25 times 55.
I take my percent at 55%,
And then take your area.
my area at 25, multiply the two together. So let's come off there just a moment, Will, so I can get down to that corner that I need. I'm going to take my 55% as a decimal times my 25 inches squared, okay? And then what am I going to do with that? Whoa, I'm not going to do that.
They divide.
Wait a minute, look at what you have here. 0.55 times 25 inches squared. So you're going to multiply. What do you get? Again? 13.75, and you have to say what? Inches squared, and that works for 20 points. Got it? Now, do you want to see it again? Back up on the screen again. Those are the numbers. Now, what's your feeling about this accuracy? Any feeling about it? You feel what? You don't repeat it. Okay, let's go off there. Now, question. Is 20 enough points to make you feel really comfortable about this?
No.
When we did 2 points, we got a half. When we did 4 points, we got 50%. We kept bouncing around. This time we're a little bit above 50%. Maybe if we took 100 points, you'd feel more confident. You got 80 more points to plot. You're getting them from exactly the same list. We did the last 2 rows, so you're just going to back up. So as I look at what you're going to do, and this is what you're going to do to turn in. Now remember, I took the last 2 rows. 2 columns, my apologies. These are columns. We did these 2. So now just back over and take the next 2 columns. So you'd have a 4, 6, a 3, 6, an 8, 6, a 6, 4. Get the idea? A lot of 6s, yes. And notice as we keep coming down, that penny just kept coming up. And then you do the next 2 columns as we come off there until you have 100. My argument is you should be getting the same answer at the end.
Should be.
Well, if everybody's doing the same points
Oh, we
and the same grid, you'll get the same answer. So how do I know if you agree? I look at about 15 or so of these and say, aha, or not so good. How do you tell if a point's inside if you don't have the camera to do magnification? Look very closely. Okay? And get a microscope maybe, or a telescope, or a magnifying glass. Telescopes aren't going to work too good here, but do something to magnify it a little bit. So that's due tomorrow. Okay? Adrian, I see you have the matching half to the ruler. The part you shared with me and a third of it? Okay, and you got 2/3, you kept the bigger half, right? Uh-huh. Okay, what a share that was. Now, what else do you need to do? Well, you need to practice the process of graphing points. So let's look at that kind of problem, and let's just see what we would do. So I'm going to draw a grid, but I'm going to put some negative values into it. So what I'm going to consider, and I'll show what I'm about here in the process, I'm going to draw a grid very similar to this on the board. So I'll show that. Now, in this process, what I want to do is make sure that we know what we're doing when we plot points. And I've assumed that because you've been plotting 20 points, you're comfortable with that. But it's not something that I'm willing to just accept. Let's review it a little bit. Now, what I've drawn here on the board, and that is because of the keystoning, looks weird. But that really is a 90-degree angle here. No, this is just a 90-degree angle. The parabola is a curve. Remember, that was the curve that looked a little bit like that? And then it came over like this. That was your parabola. I'm going to label this. Now, this is the x-axis. This is the y-axis. And this, just for your information, is called this, the horizontal axis. This is called the vertical. And this is the kind of information you need to go on into an algebra or a pre-algebra. Now, we label these, if we go back to the document cam, notice that the labeling is uniform, meaning the same spacing it's supposed to be. So the uniform labeling means I have to have positives and negatives. So I'm just going to create some arbitrary distance here and try to keep the same distance as I go from left to right. And as I do that, then I'm going to consider this to be 0. That's called the origin. So I'm just going to put an arrow up to there and call it the origin. And by the way, this was developed by this mathematician, René Descartes, roughly 1637, long time ago. And he would say this is -1, this is -2, this is -3. We sometimes put the positive numbers here, but typically we just leave them unsigned. So if you don't see a sign, it's positive. Let's see what I did in the document cam. Okay, I didn't put positives with those. Now, going again from the origin, going up, I have the same scale typically used. So this is a 1 again, a 2, a 3, and so on. And coming down, I again am going to do what? Have negatives. So this is -1 here, -2, -3. And this should look somewhat like we have in the document cam. Now I'm going to ask you a question. What quadrant is this? Okay, this is quadrant 1. Then what do I do to get to 2? Counterclockwise. Remember, that's going this way. So this becomes quadrant 2. This becomes quadrant 3. And this becomes quadrant 4. Usually designated with Roman numerals. Now I'm going to put 4 ordered pairs up here. You tell me which quadrant each one is in. What quadrant? Okay. Which is it? I'm hearing 2 and 3. Okay, it's 3. Otherwise, I'd have to start here, go negative, and then down. That puts me in the 3rd. I'm hearing 2 and 4. Negative 2, that means I go to the left and then up. Okay, next one. Well, by process of elimination, you've got 1, 3, and 2. This better be 4, right? But does it work? Go over 2, down 3. Got it? Now that's where you have to be careful, because you always start with your x. So start at your origin, and then you go either to the right or to the left. Then you go up or down. So you always start with x and then go to y. So each of these ordered pairs is listed as x comma y. And we sometimes refer to that as an OP, meaning an ordered pair, not Ocean Pacific in the swimwear you can buy. We got the notion? Now we refer to this, and listen to the phrase here, because I'm going to show you something in the process. If I look at 2, 3, so I went over 2 and up 3, correct? This is the way it's sometimes referenced. And this, if we go back to the document camp, is exactly what I have shown there with negative 3, 2. What does this shape I drew look like? A rectangle, correct? So we have a name for this. Rectangular coordinate system. So that's what this is called, a rectangular coordinate system. And here's the critical issue. Every ordered pair I get, there's a point on this graph. And for every point you see, there's an ordered pair. And here you need to understand, as we look up there, the x and the y can be fractions, they can be decimals. We are just, in this unit, doing nothing but what are called integers, positive and negative whole numbers. So I'm very restrictive in what I'm plotting. So a couple other things. Please note that we call this a graph. And again, what don't you hear in the word graph? There is no T. And we plot points. So we plot points. And that's what you're doing when you locate a point for a given pair of numbers. What is the method we are using here to find the area inside a simple closed curve? The Monte Carlo method. Now, Monte Carlo. What is done in Monte Carlo? Anybody? They gamble. Monte Carlo is a great place to go and lose. Well, it may be a car, but it's the Monte Carlo that we're referring to is a place where you go and can gamble. And what do we do in gambling? We work with probability. Same idea as probability. Who's associated with Monte Carlo? Royalty. Now, who is related to Monte Carlo in royalty? Who? Isn't it Prince Rainier? Yeah. And who was an American? This is like Jeopardy. Who was the American movie star that was in Monte Carlo as royalty? Will and I are the only two. You folks would just die in Jeopardy. Okay, Will, what's...
Grace Kelly.
Yes, Grace Kelly, Princess Grace. Ah, and she was a movie star.
I haven't done the history class yet.
Well, this is the history of math, okay, and a few other things. Boy, this is not a good day, Will. Monte Carlo is a car. Okay, who's the manufacturer? Ah, got you. Chevrolet, right? The Monte Carlo. Well, I'm talking about the one you can buy and drive on the street. Okay. Now, okay, and Merry Christmas. Okay. That was a ringtone. And Merry Christmas. Now, tomorrow, I'm going to have a test, and here's what I'm going to expect you to be able to do. Listen to what I'm asking on the test. I will give you one problem like what we did today, where you're going to have to plot 10 points, but you're going to have to draw your own curve. Just like what we did in the grid that Adrian started. Then, second problem, I'll give you a grid like I gave you today where I've drawn the curve, and you find the area. Then I will have some problems with graphing points, where I give you the pairs, you show me the graph. I will have places where I have plotted the points, and you tell me the ordered pairs. I will have problems where you change from decimals to percents, just because that's what we've been doing, from percents to decimals. I will have problems where I tell you information. So I'm planning on a 10-question test, and a couple of the problems may take you some time. I will give you a random digit table that you will be able to use. In some cases, I will have specific choices. Others, you're going to have to make the choice. So it's going to be a rather interesting test. I've got to write it yet, but it's what we'll be doing tomorrow. So, Will, as we get ready to close down here, we're in those last few minutes, we'll listen to Neil Young again.